Hello, it's Beachcam's Man and Jack from BAM, and in part one of this video, we take a look around Phase 4 and the work that's being carried out around the different cliff behavioural units, or CBUs as they're known. We watch the engineers working on the sides of the cliffs above a busy main railway line. And we also look at the 2-metre bars that are joined together to make 11-metre nails for the cliffs. This is Phase 4 of Network Rail's South West Rail Resilience Programme, and following on from the new seawall at Dawlish and rockfall shelter at Parsons Tunnel. It's all part of a government-funded programme of ongoing work on the line between Dawlish and Teignmouth, helping reduce the disruption for passengers by affording the railway better protection from the cliffs and the sea.
So like we briefly touched on in some of the seawall videos which have recently been put out on YouTube, we're going to be going over the geotechnical works that we're undertaking on Phase 4 at the moment. So Phase 4 is largely a geotechnical solution. We're not touching the seawall like we did on between kind of Marine Parade and Coast Guards. We're drilling into the cliff. So predominantly what we're doing here, we're drilling bar about 11 to 12 metres into the cliff face horizontally. Right. And what the aim is of this phase is to stabilise the cliffs and prevent the cliffs from falling onto the track, or slow the degradation of the cliffs down so they don't fall onto the track. And it's all part of South West Rail's resilience programme. So the design criteria remains the same. We're after 100 years of resilience. Yeah. So in terms of the materials that we're using stainless steel products. So where we are now at the moment is our main compound where we've been delivering all of the work from. We moved up to here from Dawlish Warren at the back end of 2023. And it was mainly just because this is where all of our access roads go down into each of the different areas. So we split all of the areas into what are called CBUs, cliff behavioural units. And today, on today's tour, we'll go through each of the cliff behavioural units and what we're doing in the work areas at the moment. So the cliff behavioural units start at number 18 and work all the way through to 26. Number 18 starts at the tunnel portal Morgan Sindles have finished. Yeah. And that runs through basically down to the bottom of the ditch here. You can see the excavator working in that section there. In between there then, that moves over to CBU 19, and there's just some weir works that we've got to undertake and diverting the water back over the weir structure which is there. That over the year the water has kind of eroded the channel out at the side of the weir, and it goes past the weir rather than over it now. Okay. So we're undertaking some works on the weir. And then we've got CBU 20 all the way through to 26 to the left of the gap and left of the cliff going up there. But I can give you an overview of each of those as we go into the CBUs, and I'll let you know what we're doing there. So the package of work really is managed by BAM Nuttall, same as what we're down on the seawall. But here we have two main subcontractors working with us. One is BAM Riches, which is a division of the Royal BAM Group. And then we've got Cans Geotechnical who are working on the cliffs. So Cans Geotechnical are working in everything to do in CBU 18. So CBU 18 is split into 3 work areas, A, B and C. Yeah. And Can are undertaking all the drilling over there. Richies are responsible for all of the drilling works from CBU 20 up, just because there's no drilling work in CBU 19. That's work BAM Nuttall are doing ourselves because it's more a civil solution. The haul roads that we've put in, these are all in landowners' properties who live in the local area. Yeah. So these are only temporary. These all get removed after. And we obviously have to make sure that the necessary consents are in place and the licences are in place with the various landowners. So in total, our haul roads, once we have all the licences from all of the landowners, extend over 7 landowners' properties. So there's 7 different sets of negotiations that we need to do before mobilising to site. And in places, there is also easements required, which is basically where nails pass underneath the boundary lines of people's properties. Okay. And there is also land acquisition required.
So these are the nails, aren't they? Sorry to interrupt.
Yeah. And also land acquisition, where we have to purchase sections of land where nails sit over the boundary line.
Right, okay.
So if the top nail encroaches over the boundary line of a resident's property, Network Rail have to purchase that land. So we do all the land access negotiations with a company called Cartage Owners, who's our acting land agent. And then most of the landowners around the Dawlish area have their own acting land agent working on behalf of them. So these here are the nails which we drill into the cliff. These are all nails which have been prepared up, ready for going in or being dropped down to the slope, and also taken out on possessions. So we undertake 2 types of drilling, or Riches and Canada take 2 types of drilling. They do face nail drilling, which is where we drop and suspend the rigs from the top using temporary works. And the rigs are then attached to wire ropes, which we can move the wire ropes to move the rig around the slope. Or they do RRV drilling, so road rail vehicle drilling, and that's basically a machine on track that comes down from one of the access points around the Dawlish area. They move into position and they have a mast on the front of the rig where they drill and bore out the hole.
And that's just done on Saturday night possessions, isn't it?
Yeah. So typically with 2 RRVs, we're getting between about 7 and 8, an average of about 7 and 8 nails per weekend. The face rigs, dependent on each of the areas, because each of them have their own challenges in terms of the geometry of the cliff and the shape of the cliff and moving rigs around. We get anywhere between 3 and 6 nails a day.
Okay.
So these nails in front of us here, we used a company called Dividag to supply these materials. We did actually design something specifically and bespokely for this job, and it was to ensure that we can achieve the level of resilience in terms of the design. So this here is what will stick out at the top, this top bar. This is stainless steel. The other bars behind it are galvanised bars.
And these join together, don't they?
That's it. They couple together with the coupler on the end there. So this one has actually been made in the factory that you can see here, the stainless steel one, and it has a heat shrink wrapper with a coupler which was specially designed for this project to allow a stainless bar to transition into a galv bar. And there's obviously stresses and forces that are put into that bar, and they have to, when Tony G designed it, the manufacturer has to ensure that bar doesn't break under under the tension of what it could potentially be retaining in terms of material if there was ever a slip inside of it.
Right. So what are they, 2 metres?
So the 2 metre sections.
And how many do you join together?
And we join roughly 5 or 6 together to make a total bar length of 11.25 metres, which is what the total bar length is in most CBUs.
Incredible.
So in this area here, we are now stood between CBU 20 and 21. So CBU 21 is just around the right side of this machine here, which we can just walk round. All of these that you can see behind us, they're basically compressors, and that's to control the air feed to the rigs as they're working on the slope, because we have to put air into the rigs as we're drilling. And then the tent that you can see over there is the grouting tent. So the type of drilling that we undertake on this project is called open boring. The rig basically attaches onto the slope and bores a hole through the front face of the cliff. The bore is left open then. The guys come along and insert the bar, and on the bar they have a spacer or lantern spacer, what we call it, which are these white things here, which keep the bar central in the hole. They then feed a line down the front face of the cliff, and they grout around the bar to secure the bar into the cliff itself. And typically in most areas, these are on a 2 by 2 metre grid space, and so every 2 metres vertically or horizontally you will see another nail. So over here now we've got CBU 20, which has actually had its permanent mesh installed, and also the coir matting. So the permanent mesh is the stainless steel stuff that you can see on the top here. And then underneath the stainless steel mesh you have the coir matting, which is to prevent erosion control, and also it does also promote growth as well. So anywhere that we've got a section of cliff, we've got demarcation around the edge, and anything past this point the guys must be clipped on as they go over the edge. So a harness, the safety ropes, and when the guys are undertaking the work we have what's called a level 3. The level 3 supervises and manages and rigs all of the ropes up at the top, and that then allows the level 1s or level 2s to work below then.
Because this is all happening while the trains are still running, aren't they?
Yeah. So this particular area here, if you just put the camera up slightly over there, you can see down the bottom, the cliff goes extremely close to the track at the bottom. And in this area here, we had what's called a temporary catch fence that was installed while we were undertaking all of the face drilling. So what that allows us to do is carry out the drilling operations while the trains are still running. Once all of the face nails were completed in the area, that temporary catch fence has now been removed. You'll be able to see that there's a section where the netting hasn't been rolled fully down to the floor. And the reason for that is because everything underneath where the catch fence was needs to be drilled with an RRV, just because of the proximity to the track. If we were if we were to drop a face rig down that low, the face rig would collide with the back of the the back of the train.
Right, okay.
So that's why we put the temporary, well, has potential to collide with the train. So that's why we put the temporary catch fence in, and we have a number of our nails which have to be drilled with the RRV. So as you come around here now, have a good look at CBU 20. You can see what I mean about the grid spacing and the patterning of the nails, roughly every 2 metres by 2 metres. The guys locally move nails in places sometimes, just so the nail is inside of a dentition. So at some points in the cliff, because of natural erosion or slips over the years, you end up with little depressions into the cliff.
Yeah.
So the guys move the nail into the middle of that depression to pull the nails and netting on tightly. The top section of the bar has some tape wrapped around it. It's called Denso tape.
Yeah.
And what that allows the guys to do in future is if the cliff does erode over the years and the netting needs to slightly be tightened up, it allows the thread to still be grout to be broken out from around that area and the thread to be tightened up to pull the netting back in tight onto the cliff again.
Right.
So this here is what we classify as an active system. So an active system is where you've got a loaded group of nails tightly bunched together, restrained in the cliff so the cliff can't move anywhere. We have got some sections of the project where we've got drapery systems, and that's more so on the sections where we've got shallower gradients or where the cliff is a lot further away from track. And that allows material to slip underneath the drapery system, but in a controlled way, and then you can clear the material from the bottom.
Right, okay.
Obviously, in this particular CBU here, CBU 20, we don't have that luxury because of the space at the toe of the cliff.
Very close down there, isn't it? And you can just see the end of Phase 3 Morgan Sindle's rockfall shelter just at the end there.
That's it, yeah. You got them down the bottom.
Yeah.
So we have got another compound at the top, which I can show you later, and another section of haul road which runs from that compound, and that's basically servicing Cannes Geotechnical. And Cannes Geotechnical ends where the black meshing is.
Yeah.
And that is CBU 18, right the way down to where the tunnel portal is in the distance.
Yeah.
So Cannes have 6 rigs working on the face currently at the moment, and they'll again move up and down, and they're averaging 5 or 6 nails a day as well with their team. CBU 20 has about 900 nails in total.
That's this one here, is it?
This one here, yeah. We're about 95% complete on this CBU. The last nails will be being drilled actually next week because we have an abnormal blockade on over the weekend. So that is, when I refer to abnormal blockade, that is a blockade where you get extended access above and beyond your normal 9 hours that you normally get on a Saturday night.
Right, okay.
So this weekend the trains aren't running for 48 hours, and we've got 6 RRVs coming into this area. 1 for Cannes down the bottom, 4 for Riches, drilling between various CBUs as we walk along now.
Yeah.
And then we've got another RRV installing a king post wall down the bottom. And then next week we've got extended access on the midweek nights as well. So we've got 9 hours per night where the train services are slightly amended on the morning to give us that extended access throughout the night from Monday through to Thursday next week. And again, a good chunk of this will be completed within those midweek nights, and that will allow the meshing to be dropped fully to the floor and this CBU to be completed then.
Cool.
Once the CBU is then completed, we begin the clean-up operation, so removing the haul roads, reinstating the boundary fences where we've taken them down, where you can see over there where we've had to create the access through at the end of a resident's property to get into the work area.
Yeah.
And then there'll be certain requirements as per the land access agreements with landowners on what the accommodation works are. For example, in this area, we've got to do some reinstatement works to one of the sheds, some fences, removing the haul road, reinstating the topsoil, and then potentially reseeding as well, just so the topsoil goes back. So this compound that we're walking through now at the moment, this services CBU 20 all the way through to CBU 23. So like I say, the grout tent set up here, all the grout gets delivered in 25 kilo bags, it gets mixed and then it gets pumped through the lines onto the various cliff faces over the top.
That green machine in the background is the pump, is it?
Yeah.
Okay.
So we have a team which is responsible for the grouting operations, and then we've got all the drilling teams as we go further down into the CBUs now. So as we come around the corner now, over the top of the tunnel portal on the opposite side from where CBU 20 was, we've got CBU 21, which basically runs all the way around through this section here.
Yeah.
CBU 21 is split between 2 landowners, so there's 2 different negotiations that we've had to undertake in this particular area. and agree land access with, and basically the boundary line is this earth bund that you can see behind us here.
Okay.
So once
last time we come up here, you didn't have this bit, did you?
No, we were waiting on the land access agreements from the landowner. It just has to go through that legal process, the solicitors, you know, the agreements from the landowner himself, agreeing the accommodation works, etc. So CBU 21, like I say, from the opposite side of the tunnel portal, round to the edge of that section there. And we have got guys drilling in this particular CBU with the drilling rigs. So like I say, everything over the edge. The guys need level 3 at the top then, so he'll be hooked on at the top then. And the bar that you can see down on the floor there connected to the turf, that's how the guys move the rig around the front face of the slope then. So pump it forwards and backwards, it lowers it, and there's a couple of them undertaking a rig move here at the moment. And again, you can see the other guys working in the opposite corner over there. The orange bag that you can see going down the slope on top of that rig is to feed bars to the team.
Okay.
So they put the bars into the sack, lower it down to the side of the rig. The operators then take the bars out of the hole and they tether the bar. So if they drop the bar's connected onto something at all times so it can't fall. Okay. And that's the same with all of the tools that they use, and that's what the control measures that we have to have in place to allow us to work above the railway line safely.
Okay.
Throughout this section there is a temporary catch fence in place, which is the blue netting, which you can see just about on the top of the tunnel portal. Yeah. And that extends right the way around the cliff. Okay. And again, that's required when we're doing daytime work and operational trains are still working below.
So this is Shell Cove below us. It does look quite similar to Corriton, but less accessible.
Yeah, definitely. So I think we've only got two rigs left in this work area now. There's not a lot of nails left to drill with the face rigs, and then the rigs will be pulled off the face. And the only thing left to complete in here then is the RRV drilling programme as well. Okay. So very quickly, the permanent mesh that you can see around the opposite side over there will carry on extending round here. Yeah. The permanent mesh is clamped to the face with they call it a spike plate. Yeah. And then a nut on top. And you can see that there's a minimum amount of thread required above the nut. Yeah. That's the control that the guys have in place when they're drilling the bar into the cliff. So when I talked about that transition bar earlier, that has been designed specifically for this job. It's so that the top 1.5 metres of the bar is stainless steel, which is a more durable material than galvanised. The reason why it's split between stainless and galvanised is by putting the whole bar in stainless, it would have cost us an extra £9 million. And there's no real benefit. You don't get really any benefit. So that's why we asked Iridag to specifically design that coupler for us.
Okay, huge savings there.
Yeah. But like you can appreciate that each nail is probably 12 metres in length. Yeah. And each nail is 12 metres in length, and there's about 5,700 nails to drill in total, which is about 60 kilometres of bar. So there's a lot of bar going into the cliff.
Yeah, that's a lot.
The suppliers had struggles keeping up with us really in terms of the bar delivery.
You're moving very quickly from the last time we came. How long ago was it we came over? You just sort of starting then, weren't you?
Yeah. So the road splits then. This carries around to the top of 21, and then this is the service line in through where the old hotel used to be, up through here. Yeah. And then that feeds the work areas over CBU 22 and CBU 23. Okay. So when we're undertaking all of the drilling works, we have what's called a COS, supervising the work area, so that's a controller of site safety. And in the unlikely event that something does occur where something does go onto track, the COS can contact the signaller to let them know that there's an issue with the track. So everywhere the guys are working, above the cliff, we have a COS working with them, who has communication back to the signal box and to let them know if there is any issues. So as we come down through this section now, this is the residents' access down to the beach at Shell Cove, and this is where our COS supervises the work area from, so we can see both sides of the work areas over here. So this is CBU 22, pretty much right the way round through to where that line appears in the cliff face over there.
Well, this was still full of trees when we came over last, wasn't it?
Yeah. So the trees will go back through the netting eventually. And the vegetation will grow back. It's just that we have to take the trees down to put the net in and wrap the netting right over the cliff face, because you can't have cut holes through it.
Absolutely.
But it will start to grow back over the years. The tree roots themselves, they do a job of stabilising the cliffs, but only very, very minor surface slips, not the surface slips that this has been designed to restrain. The roots don't go down 12 metres into the ground like the bars will. No. And obviously there's no design life to a tree. So you can see the team over on the opposite side now, just below where we were stood with the work area. The blue pipe sticking out of the bars there is the alkathene pipe where they pump the grout through, and that's what they put inside of the hole, and that's, you can see the kind of some of the stains where the grout's been pumped into the holes, into the cliff face itself. And again, you've got the permanent meshing that's been undertaken around the side of the tunnel over there, and that'll be wrapped round back into this section.
Yeah.
So we have to put this temporary matting on everywhere we're undertaking drilling works, and that's to retain any potential drill horizons that come out of the bore of the drill, or any material that's loose on the face. And this temporary netting here will allow that material to safely go down to the bottom of the cliff, inside between the cliff face and the netting, and not the outside.
Yeah.
This particular CBU has been nailed before. There was some nails in the top third of this, which were installed back in 2008. That's why there's no nails at the top third.
Okay.
You can see the nails as you come around that corner there, and we're reusing those nails as part of this design solution. Again, it saves a lot of time and money not having to re-drill all of those.
Yeah.
You can see the train coming through now and just how close we are working to the open line, which is below. It's just coming underneath the tunnel as we speak now.
Yeah.
So we won't go all the way down, but this is CBU 22. There's a drilling team just on the top of the tunnel portal down there now. We did also have 2 drilling teams on this section of the cliff over there, but there was you can see the material at the bottom there. There was a slip on the face as the team were undertaking the drilling just because of how loose all the material is at the top. So what we ended up doing is taking the black temporary mesh off, because it's kind of like a plastic sort of material, I think it is anyway.
Yeah.
And we've had to remove that to put a galvanised netting as a safety net on that section, because it was ripping where that slip happened. You can see the black netting that pulled off the face.
Yeah.
So we've had to change the method of installing that over there. And you can see on this particular CBU, we've actually put the plates on to restrain the netting to the face and give it more strength.
Okay.
Rather than in all the other CBUs, the black netting just drapes from top to bottom.
Yeah.
Just to retain any potential slips that do happen in there on the face, rather than coming down, rather than the workforce working below. So that's the control measures that we put in place for over there. So we review it from a design point of view, we review it from a safety point of view. Design, it doesn't really impact the design, because the nail's still got to be drilled into the cliff.
Yeah.
But it further strengthens why we are here with working on the cliffs itself. So these CBUs here, because of how far they are away from the railway, if you just look over the top of this section, you can see the railway down the bottom there, and our temporary access ramp that we've created up with our excavator.
Yeah.
And this CBU here is actually full of a really loose material off where all the material has washed down off the cliff over the years and collected at the bottom. So we call it talus. And we have got to do some regrades throughout this area and remove that loose material, because it does have the potential to mobilise and slip.
Yeah.
Now, if you can imagine, the natural point of direction down here is a track. So if that material does slip and does mobilise, which it has in some areas, you can see a hole. You can see that hole just in front of there? So that material there, before we even started on the project, that material slipped down to where that tree root is there.
Okay, yeah, I can see that.
So we are having to redesign a section of this, because this was meant to be split into 2 drapery systems. One where it comes down to where the pipes are there.
Yeah.
And that's the surface water, the pipes that are there is the surface water drain off from the developments above, and a drapery system below then. And because that slip has occurred inside where the drapery system is, we now need to amend the design in this area, because we can't put the anchor blocks in to restrain it.
No.
And you can see where some of the material's actually gone down the footpath there.
Yeah, yeah.
And how wet and loose it is at the bottom. So once we've completed in here, we'll undertake the talus regrade works, which we can get some footage on over the next couple of months as we're undertaking them.
Yeah.
And we can also get some more footage of the work areas in CBU 22 as they're undertaken. The galvanised mesh that I've talked about over there will remain in place, and then we'll put the coir matting and the stainless steel mesh over the top of that once complete.
Right.
And all of the slip material, which has slipped, we'll remove as part of the talus regrade
So will that
works.
go via RRV?
There's a couple of options with it. So we can there's something called a vacuum excavator. But the best way I can describe it, it's like a big Dyson.
Is that what you used on the platform?
It is, yeah.
Okay.
And that actually has the ability to pump from this lower level down here all the way to the top of the cliff.
Wow, that's some power.
Yeah. So you don't want to be on the wrong end of the nozzle. So yeah, the vacuum excavator, we are potentially going to be using that from the top. and lowering that down the slope, the chutes for it, and that will suck all the material up from the top down. And the reason why we don't want to use the excavator to dig out from the bottom is as we've mobilised into this area, we didn't fully appreciate how wet this area was because of all the runoff from the cliffs. Yeah. And moving the excavator around in there is very difficult, and digging the material out from the bottom, you have the potential to mobilise material. So it's much safer to work from the top down, sucking the material out. So I think that's what we're going to be using. We're just waiting for one of our contractors to give us a price for undertaking that work.
Okay, so how did you get that excavator there?
So that excavator came on the back of an RRV.
Okay.
And then we use what are called poly blocks, which are those white blocks down the bottom there, about 50, 60 kilos each they are. And they're on top of the road plates, which protect the trough-in, which where all the cables run line side through. So there's a temporary works design in place for actually getting that excavator into there. Right, okay. We have to have a temporary works design, and that has to be approved by the construction team before we install that temporary works. Yeah. This particular CBU does have access down onto the beach, which you can see via that little kind of footpath down there, and the underpass there, which there's a bridge which goes underneath the railway, but we're not going to be going down to there. No. And there's two other things which I've not mentioned yet: the replacement of the catch fences. So at the bottom of CBU 23, so like I talked about earlier, that little line where you can see coming down where grass starts to grow back, that is the boundary line between CBU 22 and CBU 23.
So along that corner.
Yeah, yeah. And 23, that's all going to be an active system just because of how close it is to the railway. Yeah. And there is also two catch fences. They're both covered in vegetation, but one runs directly adjacent to the railway line there, and then the other one runs over the top of the tunnel portal. And with those catch fences, we're going to be replacing the mesh on the front of them with a stainless steel product rather than a galvanised product, which is there at the minute, to give it that design life and that durability. Yeah. And also some of the boards are rotten. Okay. So in terms of our welfare, all of the operations that you can see here are run out of the main compound at the top.
Yeah, that's on Timoth Road, isn't it?
On Timoth Road, next to Smugglers. And then we have another compound at the top for cans. And we also have a small compound at the top of Lee Mount in the park. And that's to deliver the works in CBU 24, 25 and 26.
Ingenious way of topping up that tank.
Genius, isn't it? So just so we don't have to run water feeds all the way down from the main road, so both compounds are on mains feed from the public highway, and also mains electricity as well, just because it reduces our carbon footprint in terms of using big diesel generators to power all of this kit up here. Yeah. So we connect it up to the mains and remove the connections on completion of the project. So the guys fill up, so we don't have to run the mains feed all the way from the top compound all the way down to the bottom here. We fill up the IBCs at the top then, which is what that big block was then. And we fill them up at the top, and then we bring them down here with a forklift and put them into the bowser. And the reason for that water bowser being required is for all of the grouting operations. You can imagine there's a lot of water to mix in with that grout to get the volume of grout needed to fill each of the holes in the cliff face.
We really hope you enjoyed this video. So join us next week for part 2, where Bam Nuttall finds a historic pipe from the Brunel times. We take a look at the high cliffs that they are working from, and an unknown brick face is discovered behind the sandstone cliffs. If you're a VIP subscriber, you can watch part 2 now, and if you want to join for our 10th anniversary, just visit coastcams.me/10.